Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Ozonolysis of aromatic compounds. 1 Auwers ozonolysis cleaves all 3 double bonds of the benzene ring, producing carbonyl fragments from each double bond. Moving on to the next step. Identify the structure. The starting material is ozylene, 1,2-dimethylbenzene, which has a benzene ring with methyl groups on adjacent carbons, C1 and C2. Moving on to the next step. Number the ring carbons and label substituents. C1 has CH3, C2 has CH3, and C3 through C6 are unsubstituted. And for the final step, ozonolysis cleaves each C is equal to C double bond of the kekulé structure. The 3 double bonds in one kekulé resonance form of ozylene are C1 is equal to C2, C3 is equal to C4, and C5 is equal to C6. Cleavage of C1 is equal to C2. Both carbons bear CH3 gives CH3, C is equal to O from C1 and C is equal to O, CH3 from C2 which recombine to give CH3, C is equal to O, C is equal to O, CH3 is equal to 2, 3-butadiene, 1 molecule. Cleavage of C3 is equal to C4, both unsubstituted, connected to C2 and C5 respectively gives HC is equal to O fragments. These are the terminal aldehyde carbons. C3 is connected to C2, which gives C is equal to O, CH3, and C4 is connected to C5. So C3 fragment HC is equal to O, and C4 fragment HC is equal to O dash. These join with adjacent fragments. Cleavage of C5 is equal to C6, both unsubstituted, connected to C4 and C1 respectively. C5 fragment HC is equal to O, and C6 fragment HC is equal to O dash. Assemble the linear chain of fragments from ozonolysis of the ring opened as a chain C1, CH3, C2, CH3, C3, H, C4, H, C5, H, C6, H, back to C1. Opening gives the dialdehyde chain OHCC, CH3 is equal to O, vertical bar C, CH3 is equal to O, CHO vertical bar CHO. More carefully, the 6 carbons in sequence give 3 decarbonyl products. C1, C2 bond cleavage, both methylated CH3 COH3 is equal to 2, 3-butadiene, 1 mole. C3, C4 bond cleavage, both HOCHO is equal to glyoxyl, 1 mole. C5, C6 bond cleavage, H and CH3 adjacent, but we must pair C6 with C1, CH3, and C3 with C2. Reapproach systematically. The ring opens into 3 2-carbon units. The pairs are C1, C2, both have CH3, 2, 3-butadiene, C3, C4, both have H-glyoxyl, C5, C6, 1 is adjacent to C1, CH3, giving C6 as CHO end, C5 as CHO end, but C5 is adjacent to C4, H, and C6 is adjacent to C1, CH3. Actually, each carbon becomes 1 carbonyl. The 3 products come from pairing adjacent carbons across each cleaved double bond C1, CH3 plus C6, H, CH3 CHO is equal to methylglyoxyl, pyruvaldehyde, C2, CH3 plus C3, H, CH3 CHO is equal to methylglyoxyl, pyruvaldehyde, C4, H plus C5, H, OCHO is equal to glyoxyl. Glyoxyl is equal to 1 molecule. From C4, C5 cleavage, pyruvaldehyde is equal to 2 molecules. From C1, C6 and C2, C3 cleavages, 2, 3-butadiene is equal to Wait, this doesn't give butanediene. The correct Kekulé pairing for oxylene ozonolysis, double bonds are C1 is equal to C6, C2 is equal to C3, C4 is equal to C5, alternate. Cleavage C1, CH3, C6, H, methylglyoxyl X1, C2, CH3, C3, H, methylglyoxyl X1, C4, H, C5, H, glyoxyl X1. Other Kekulé, C1 is equal to C2, C3 is equal to C4, C5 is equal to C6, C1, CH3, C2, CH3, dash butanediene X1, C3, H, C4, H, dash glyoxyl X1, C5, H, C6, H, dash glyoxyl X1. Average of both Kekulé structures, glyoxyl is equal to 1 plus 2, 2 is equal to 1.5, pyrrolidhyde is equal to 2 plus 0, 2 is equal to 1, butanediene is equal to 0 plus 1, 2 is equal to 0.5. Ratio glyoxyl, pyrrolidhyde is equal to 1.5, 1 is equal to 3 2. 2 why other options fail, 1 3 and 3 1 don't reflect the averaged fragment count, 2 3 inverts the correct ratio. Therefore, the correct answer is C. Therefore, the correct answer is option C.